Good morning all. I Salim, Assistant Professor in Electronics and Instrumentation Engineering Department, Kite Group of Institutions, presenting you functional elements of an instrument. Basically, first of all, we have to know what is the definition of an instrument. Scientists, engineers and other humans use a vast range of instruments to perform the measurements. These instruments may range from simple objects such as ruler, scale and stopwatches to electron microscopes and particle accelerators used by scientists and engineers from low level to high level. An instrument is a device or a system which is designed to maintain a functional relationship between prescribed properties of physical variable being measured. It provides the means of communication to a human observer or a operator of the machine or equipment. The above stated functional relationship remains valid only as long as the static calibration of the system remains constant. The performance of an instrument of a measurement system is usually described in terms of a set of static and dynamic characteristics. These characteristics includes like accuracy, resolution, precision, errors, different types of errors, linearity, etc. Here are the functional elements of a measurement system. To understand a measurement system or instrument, it is important to have a systematic organization and analysis of that measurement system. The operation of a measuring instrument or a system could be described in a generalized manner in terms of functional elements. Each functional element is made up of a components or a group of components which perform their required task or defined task. The main functional elements of a measurement systems are first primary sensing element, then variable conversion element, then variable manipulation element, then signal conditioning element, then data transmission element, and last data presentation element. Here is an example of functional element of a Bourdon pressure gauge. Here first we have to measure pressure as this is a C type Bourdon tube. As the pressure increases or decreases, this C type Bourdon tube compress or expand on the basis of pressure input. As the pressure increases, it expand, and as the pressure decreases, it compress. So here is a link attached with this sector. As this expand and compress, it moves, and as it moves, so it produces a linear motion, and this linear motion is converted into rotatory motion using this gearbox. So here in this example we converted pressure reading into distance measurement, and over here we calibrated our scale. This is the scale of pressure for the pressure measurement. It is calibrated in terms of pressure. So as the pressure increases or decreases, this pointer also moves from 0 degree to 1000 degree, and we get the readings of pressure. So functional element of a Bourdon pressure gauge are as follow. The simple Bourdon tube pressure gauge as shown in figure. In this case, the Bourdon tube act as primary sensing element and a variable conversion element also. It senses the input quantity which is our pressure. On account of the pressure, the closed end of Bourdon tube is displayed. Thus, the pressure is converted into small displacement. The closed end of the Bourdon tube is connected through mechanical linkage to a sector pinion gear arrangement. The gear arrangement amplifies the small displacement and makes the pointer to rotate through a large angle, and the mechanical linkage thus act as the data transmission element, while the gear arrangement act as data manipulation element. In this case, the dial scale on the gauge body plays the function of data presentation element, which is our last element, and conveys the information about the quantity being measured. The information conveyed by this device is in analog form in this case only. This is all about functional element of an instrument. Thank you.